So in order for us to be able to write the DAX, I think it is very important that we start with the mathematical and statistical function in DAX, because most of these functions are used when we are writing like a more complex DAX expression. And the full meaning of DAX is, I think, this data analysis expression or something like that. So in today's class, I will be using a transaction table that I pulled into the data set yesterday. Let me show it to you. So I pull this transaction table. Okay, let me just close this. So yesterday we pull in the transaction table here, and also we are able to pull a direct query using one of our I think, let me say, a pre-built select statement in SQL. So let me just try and show that. So let me do like a short recap. So if you want to connect to your pull data from your SQL server, you have to connect to your SQL server first. Just click on the connect, and my server name is BD, right? So if you come here, when you click on the get data, if you choose the SQL Server database, if I choose this and I click connect, sorry, then I'll put my server name and I can connect using either of these data connectivity mode. We're able to use the import mode yesterday to bring in all this data. And we also use the direct query to bring in the data. I'm just going to do like a short recap. So let me connect by pulling using the import radio body. You can see that the database, this is the Adventure Database Box 2019. And these are the views that we have in our SQL server, and these are the table. So for the sake of those that mixed yesterday class, this is the simplest way for you to connect to the SQL server, to the Adventure Work database in the SQL server that we use for our SQL class. So that is that. Another one is, okay, so you can just choose wherever table you want to pull into your Power BI. And this is the preview. So this canvas shows the preview of the data you're pulling into your Power BI desktop. And we can also do like a kind of transformation from here by clicking on transform data. So this is a very simple way to bring in your data using the get data by connecting to the SQL server using the import radio option. So that is that. So let's say we want to connect using the direct query. Let's just take a look at the tables. So let's think the apples. Let's do this. I think this is one of the table that maybe the derived table or store procedure or whatever that we built. So let's assume I just want to bring this into my using the direct query. I'm just going to copy this code. And I'm going to come here. I will do get data. Then I will do SQL Server. And my server name is ED. and I will do direct query, and I will come to the SQL statement. Can you see? Requires database. So this will be Adventure Works 2019. And I'll just paste my query here. So I'm pulling this database object name babe. I'm using the direct query to pull instead of using the import radio button option. So I'm just going to do OK. Can you see I have a table now here? So I can also load the table into my Power BI canvas and start doing my data manipulation or whatever I want to do with it. So that being said, this is another method for you to undo your data manipulation or your data transformation or perform an aggregate function from the SQL level when pulling your data into the Power BI. So that is another option using the direct query. And the output of this direct query is going to be in form of query. It's going to be like query one. And okay, let me just finish this so that you can understand it. Potential security risk. Okay. Can you see? This is the new table I'm pulling in. It's sales query one. So this query, the output is going to be in form of a relational table. The output will always be a table that has a column and that has a row. So if I go to my table view and I click on the query, the table cannot be shown simply because it is not in import mode. But let's do this. Can you see? I want you to pay attention to something. Can see that the table that we generated by using the direct query, look at the icon that is at the lower edge of the database, or like the table rather. You can see we have an upper arrow and we have a down arrow. I can also rename this query one to whatever table name I want to give it. So that is that, but I'm just going to delete this away from this model. Delete from the model. So please, it is very important that you watch yesterday's video so that you won't get to probably get lost by the time we are getting to the DAX expression advanced writing and stuff. Mr. ID, please go ahead.
The direct query that we did yesterday, we're able to view it now. No, we noticed that the data view did not come up, only the report and the model view came up. But I'm wondering why it's not viewable now.
Yeah, you started yours from the beginning yesterday. I have some existing table here. So if I want to form any relationship or I want to build anything with it, if I refresh it, it might even come up.
Okay.
So it will always show up. I'm just using that as an example.
Okay.
Yeah. So that is that. So let's get to today's work. Please, if anyone is still having issue downloading the Power BI desktop, you can go to the Microsoft product on your PC and put in a Microsoft Power BI desktop. You should be able to. It's pretty very easy. It's as if you are just installing a software. So that's that. Let's get to today's work. So the mathematical and the statistical functions in DAX. These are all pre-built functions. We have a lot of them. But for the sake of this class or for this session, I think starting from the easiest function is the best way to introduce us to writing the most advanced DAX. So basically, this DAX writing that we're probably going to master or practice in this class is going to be very similar to the way we start writing our functions in Excel. I will start from the simplest one, and afterward, I will be combining this function in a single DAX expression. But to start with, I will write each of these DAX expression using the transaction table that we have, that I attached in the mail I sent earlier to you today. We also pull in the transaction table into our Power BI yesterday. So I have it here already. And I will use that. I think one of our DAX expressions only pulling from the, let me see, is only pulling from other table. So we have transaction, and transaction. Let's see. Okay, let's just get started. So the first one is sum on the list. So what sum does is that it adds all the number in the column, right? And what is the difference between sum and sum hex? So sum X will start from the table level and will accept an expression. And it will return a sum of an expression evaluated for each row in a table. So to start with, let's just start writing it one after the other. So I'm going to make reference to transaction table. And let me see, I think I have to delete this. Let me delete this. Delete from model. Delete from model. So to write the DAX expression for the sum, what you need to do is that you just have to click on new measure. The measure is used to calculate. A measure will always give you a single value, will always return a single value. A calculated column will always return a single column populated with records. So let's write our first measure. So if we want to write the sum function, I'm just going to use the transaction table as my reference. I'm going to name this to be sum. I also copy the DAX expression in the material I share with you. So if I do sum, you can see it's pre-built in the Power BI. Then I'll do my tab. Then I just want to sum the price column in the transaction table. So what I'm going to do is that I'm going to do single open quote. Then I'm going to do transaction. And you can see by default, it lists the T listed the transaction, which is the table, and all the columns in the table. We have the business entity ID as a column in the transaction table. We have the price as a column in transaction table. We have the transaction date as a column in transaction table, and we have units sold in the transaction table. So for the sake of this class, I just want to sum the value of the price that we have in the price column. So I'm just going to select this. I'll close it, and I'll do enter. So now I have my sum measure. You can see the measures looks like, the icon looks like what? Like a small calculator, right? So let me throw in my card to display the value for the sum. So let me select this. So this is my value for the sum. So for formatting's sake, I want to be teaching you how to format as well. You have to come through the way to this icon that look like a small brush and like an histogram or something. Just click on it, and let's do general. You can give it a title if you want to give it a title. Can give it a title. If you want to do effects, you can add background to it. You can add background color to it. Let's say I want to do blue. Can you see? So you can do so many things. Let's just
the title, you didn't turn it on.
oh yeah. So
So if
for
you
the
select
type I've
the
turned
drop
it
down,
on, but I think you have to pass a
drop down,
value to it.
exactly.
So this is gonna be sum of price. Can you see? We have it here. So basically, the formatting of your visual is going to be at the can you see where it says format visual. It has a lot of properties. You have subtitles, spacing, effect, background, everything, the tooltip, and the likes. So whatever you want to do, you can just put it there. So that is that. But what I want to do is that I want to let's do color value. I want to remove this is like an auto, right? Because it summarizes it to be 13K. Let's just display, let's choose none. Okay, so this is the exact value. And do we want it to be indexed? I think this is fine. So this is how to create a measure for a sum. And the sum is used to calculate the total, like performing an aggregate function, like calculating the total value in a particular column. So that is that. So the next one on the list is what? Is the sum x. So what is the difference between the sum x and sum? I want you to have it at the back of your mind is that whenever you see an x, like sum x, it means that we want to sum the total value of two different columns. For instance, I can multiply, take a look at this. It says transaction, this is the table, transaction units sold multiplied by transaction price, right? Instead of writing this sum for the unit sold separately and writing the sum for the transaction price separately, you can use a sum x since it is an expression, the table name and then the expression. Let me show you how to do that. Before I proceed, let me show you this so that you can understand what I'm trying to say. Where's my transaction table? Okay, so what I'm trying to do now is this. You know, if I want to know if I want to sum the total value for, like, let's say units sold by price, this is going to be iterating on a row level, right? I will do 22 multiplied by 23, the value, which is, I can say the total price, right? If I can create a new column, right, and calculate a total price for based on the units sold and the price. But instead of creating a calculated column, I can create a measure that will do the summation for the total of all these transactions. What it means is that 22 multiplied by 23, the value is going to be added to 11 multiplied by 23, all through to the last record that we have in the unit sold and the price column. So let's, do you get my explanation? Instead of undo this manually, like creating a calculated column to do like unit sold multiplied by price and get the total amount realized or the total item purchase or whatever. Instead of creating that, I can just write a sum x DAX expression to handle this, and it will give me a single value for the total of all the transaction purchase from the first transaction date and the last transaction date. So to do that, let's create a new measure as well. I'll do new measure. So I will name this to be some x, and I will do some x. So I want you to always pay attention to something. At the top, you can see that it says some x, the table that you want to use to conduct your aggregation to perform your calculation is what? In our case, we are using the transaction table. Then I'll come here I'll select from my transaction table, comma. I want you to do what? I want you to do transaction unit sold, right? Multiply by transaction price. Then I'll do what? Then I'll close it up. So now, give me the sum of whatever. This is an iterative process. It's going to start from record 1. This transaction is going to start from record 1, jump to record 2, all through the last record. After the last record aggregation has been performed, then give me the sum of the value. We are using sum x simply because we are passing an expression into our dash. I use sum function simply because I'm just calculating the sum of a particular column. But now I'm calculating the sum of what? Of 2 columns based on the multiplication what? Operator. So let's do enter. So let's go to the format. I'm also going to take a new card. New visual. You click on new visual. I'm going to change it to card, and I'm going to select some X. So let's go to our visual. Let's do the colored value. Then I'm going to change this to none. So this is the total amount realized from the first transaction date to the last transaction date. This might be for a particular month or whatever. So this is the total revenue or total sold, total amount generated in that store for that from a particular start date to an end date. So you can see that the sum only calculated based on, this is the sum of all the price, but this is the sum of all the goods sold. So if manually, for the sake of those that are still learning, you can do the sum of price and do the sum of units sold. Maybe let's do that just for clarity's sake. Let's do another new measure. So I want to do sum of let's do sum of this is sum of price, sum of goods. Mr. ID, go ahead, please.
Yeah, is it going to work that way? Because you cannot just be summing price and be summing units sold separately. We have to multiply price, have another calculated column for.
Yeah, I want to show you there's so many ways you can handle it.
You can
We
do
can
it. Okay.
we can create a calculated column for that. I
Okay.
just want to show them how I want to show you how I arrive at 275,000.
Okay.
Okay, yeah. So I want to take a sum of the goods and I will multiply with the sum of the price and see if I will arrive at 275,028. So that is what I'm just trying, just to be able to understand how we get this, use this sum X instead of going like 2-3 different steps, what the sum X expression can really handle. So let's do sum equals to, okay, let's do sum. Then we do transaction, the unit sold. So now we have the sum of goods sold and we have the sum of price. So let's create a new measure again, just for us to see if we'll be able to arrive at this. So let's do new measure. And let's do, I'll do goods total. Then I'll do sum multiply by sum of goods. So I'm going to go to my home. Let me bring a new visual and let's do sum of goods total. Let's do card. So the sum of price, the sum of goods, the sum of price, the sum of goods. Okay. So can someone multiply 13114? Let's see, sum of units sold. Oh, no. So this is sum of goods is sum of units sold. Which one do we have to use? Okay, goods total, rather. That was like, okay. So the goods total is giving us 101 million. Can you tell me the reason why we have this? Anyone want to try? So we have the sum of the units sold to be sum of the goods sold to be 13141, and the sum of the price okay, sum of the price is 1341, and sum of the goods sold. I think there is an error here.
I doubt if it's going to work, because what some X you have done with some X is like coming up with a total value without necessarily having a separate column for this calculation. But now you want to demonstrate it now by multiplying the price with the quantity, getting a column for it, and now summing up the column, which is like two-way step. You first multiply price by quantity to get the column. You now sum the column together to now see the equivalent to it and 275028.
Yeah. So the thing is this. If you take a look at the sum of the price is aggregating a particular column to give us the price for that column. And the sum X is doing what? Let's do sum X. So the sum X is doing the transaction of the units sold multiplied by the price. This is an iterative process. It's doing the calculation at the row level. And for this goods total, what it means is that if the value of sum X at the row level that is iterative, what it will give us if we do a separate calculation based on the measure, it's going to be a different thing. I tried this simply because I want you to understand that there is a reason why we have to use sum X, and there is a reason why we have to use this. It all depends on the problem we want to solve. But there is one thing I just want us to confirm. Can someone please just multiply 13141, which is the sum of the price, and let's say the sum of the goods. So the sum of the goods. Let me bring in a let me bring in a new visual for some of the goods. I'm going to change this to some of the goods. So definitely, if we multiply this by this, it's going to give us 1 million, definitely. So for the sum X, the value the sum X is going to return is different from the value we will have if we write a different measure for each of the row, for each of the column rather, for each of the column. This is the sum of the price. This is the sum of the total number of goods sold. This is it. If we multiply this by this, it will give us 101 million, which is different from this. Mr. ID, does that answer your question?
No. It's okay. You know the simple logic behind this thing is I know some S is used to just to make the work faster. Number one, because it's going to give you the total value. And also sometimes if you also want to hide some things from another person that might want to know how you went about certain things, you can make use of this. And also to also save space. You know, but the way this one is now is like when you are multiplying 2 multiplied by 2, 2 multiplied by 3. You have a number of quantity, you have the price. If you multiply 2 by 2, 2 by 3, it will give you 4, 6. You sum it together, it will give you 10.
10,
yeah. But what you are doing now is that you are adding 2 and 2 together, which is 4. You are adding 2 and 3 together, which is 5. You are now multiplying 4 and 5, which give you 20. So you can't get the same answer.
Yeah.
But
so let's do something again. Sorry to cut you short. Let's write a calculated column for it again. The reason why I'm doing all these things is just for everyone to learn how this DAX expression behaves. Do you know why? Simply because by the time you are working on a live project and the customer is telling you, okay, you know what? The result you are getting is different from what we have. And yesterday, I think in our discussion, I said, whenever the value of what you are capturing in your report does not tally with what the customer seems to get during your validation process, it is very important that you take your DAX expression, right? And also go back to your data transformation stage. I think that was part of what we discussed yesterday in this class. Yes or no, Mr. ID?
Yes.
So it is very important as a developer or as an analyst for you to know the right syntax to use. This is also an interview question. They might ask you if they give you a record that has so value, and they give that has a so value that has a 5 record that has a specific value, and that has 2 columns, and you want to multiply 2 columns together. Will you get the same value if you use some X or you calculate each of the columns separately? So that is what Mr. ID have just answered. Do you get what I'm saying? It is very important that we know what each of these DAX expression can undo. Because you can go online and just look at the syntax and throw it into your Power BI and build whatever DAX, write whatever DAX you want to write. It is very important that you know the limitation of each of the statistical function that it is in Power BI. So that's that. Let's create a calculated column to just see what the result we are going to get for that as well. Let's do let's do new column. New column. Let's do new column. So what do you want me to call this? Total
You can
purchase
call
or
it purchase or sales.
purchase of okay. Purchase or sales purchased. Then we'll do. No, it shouldn't be here. It should be.
I guess maybe because you've clicked. It's as if it's looking at it as if you have completed your
Supposed to be on this column. Yeah. Let's call this sales purchased. So another thing I would like to say is that troubleshooting is part of what we must learn. Whenever you write something and you believe you are not getting the right value, you don't have to bother yourself, just have to go back and do it. So to write my calculated column, what am I going to do? I'm going to do transaction, right? It's going to be transaction price, right? Multiply by transaction what? Transaction sold. Let me delete the purchase of sales. Delete. So the next thing for me to do is that I want to take a sum of this sales purchase. Let's do new measure. Let's call this sum purchase, Abby. Let's do sum of this. Oh, sorry. I'll select this. So let's go to home and let's do new visual and let's select the card and let's do sum purchase. So when we do it at the calculated column level, you can see the price. Okay, let me do this.
No, you might need to remove the none. Yeah. I mean, make it a none.
Yeah. So can you see when we introduce the calculated column, we get the same value for this sum hex. That shows where's the transaction table. So what this does is that the calculation of this at the row level that the sum X is doing, if you add this 506,253 all through the last record, it's going to give us the 275,000, which is equivalent to the sum X expression that we wrote. So the best practice is to avoid summing this column and summing this column and summing this price column and multiply the total of the two together will never be equivalent to the sum of what you will get at the row level. You guys have any question? So the right thing to do is to use either go to the route of the sum X or go to the route of what? The calculated column. Don't do this and don't do this. Any question? Can I proceed to the next one?
So going through the route of calculated column, so is it the best because performance issue will now come up?
Mr. ID, which one do you think is the best one? Anyone can try as well. Let's make this class to be interactive. But this is how we can learn the terminologies apart from just knowing the right thing. So which one do you think is the best that we're going to have the best performance instead of this and this? Which one will have the best performance?
I think based on what we have done, SumX is better in terms of performance. It's going to be faster, and it's going to also save us additional space, because now we are looking at maybe like few rows or whatever. We are now looking at a transition of multiple rows down the line, maybe for like 2, 3, 4 years. We are trying to sum a particular thing. It's going to take time doing it row by row first to get the calculated columns before we to now be looking at the summation together. So I think SumX to me is better if you are looking at performance.
Okay, so thank you so much for that. Let me show you something real quick. For the sum purchase, how many steps do we take to get this total value? For the sum X, how many steps do we take? Let's take a look at this. So we have the sum X. So the sum X is just looking at from the transaction table, perform this. But for the sum purchased, we did what? We created a calculated column first. That was the first step, right? Afterwards, then we write a measure to calculate the additional column that we added to our transaction table. That shows that we have like 2 or 3 steps, which is going to take a while to run. Because before you can get the final answer for this, the data that is coming from your live database, this is like a kind of a staging area that we are using a kind of pre-selected data based on the data we select today. That is what we are using to build this. But by the time this database is being, this report is being published in the Power BI service or the website, converted to an application, it has to pull data from the live database. Whenever it's pulling data from the live database, these are the steps that the data will pass through before you can get these results. So this is going to take a while. This sum purchase is going to take a while, but for the sum S, you'll be able to get the value at a fly, simply because this sum X is just looking at the incoming data that is just coming from the live data to calculate this. But in the case of the sum purchase, it has to add an additional column to the existing transaction table, and afterward, it's going to perform a sum operation on the purchase column, on the additional column we added to the transaction table. This is taking longer. This is take a very little time to run. So this will be more, the performance of this will be higher compared to this. So this is the best way to go, sum X. But for the sake of those that are probably not so very good writing DAX expression, you can do this. But if in your organization you don't have a Power BI code review committee in place, they might actually approve this for you. But if you have a Power BI code committee in place, someone like me, I will tell you, I will throw in this sum X DAX expression to you. Instead of doing this, why don't you do this? But I have a question for the house. So if we have other DAX expression that is going to use the calculated column, do you think we have to go through the route of this measure that we created? I want someone to answer that. If we have other DAX expression that is dependent on the calculated column that we create, by the time we are using a filter, by the time we are combining like 2 functions, by the time we are performing a logical operation, this might be the best route for us to go. It all depends on the question or the problem we want to solve. If other DAX expression is going to be directly dependent on the calculated column or the additional column you create, this is going to run faster compared to building numerous measures. So that is that. It all depends on what problem you want to solve. That is very, very important. So let's go to the...
Please, before you go.
Okay.
I need you to clear something for me, okay?
Okay.
Can you use numbers? If you can use the whiteboard, because I want to get these figures that you are getting here, okay? If we can use just 3 numbers when you have your unit sold and price, and we do just the sum of the units sold, and then the sum of the price, then you multiply probably the units sold times price. When you said which one do you need to choose from, I know it will not give you the same value, but which one are you choosing and why are you choosing that one?
Okay.
So if you go now, if you can use that 22, 23, 11, 23, and 2.
Okay, you want me to use this table? Okay.
Yes, just use the three of them, just the first three. Let's use it and see.
Okay. So if I get you clearly,
Right.
You are trying to ask me which one is the correct one.
Right.
Okay. So the calculated column, let me show you this. Both are correct. But this, which is the sum X, the sum X is pulling from the transaction table. And from the transaction table, we are multiplying the units sold and the price. Let me show
That's
you
right.
we are multiplying
right
this
here.
and this. Yes.
That's right. That's why you are getting 506, 253, and 46. The total will give you 805 or thereabout.
Yeah,
But if you add, yeah.
So what we did, the calculation is based on the total rows that we have in this data table. It's not just on 3 tables.
No. I'm just using that simple one to make it simple for my head to get what you are doing. Yes, I understand what you were doing. But I am saying if you are using just these 3, if you add this 506 to 446, it will give you 805 or thereabout. But if you add up 22, 11, and 2, that will give you like a 35. And you add up this 23, 23, 23, it will give you 69. So if you multiply that 35 by 69, it will give you about 2415. I know it's not the same thing here. So the 806, the 805 is the one that you say is correct.
Yes.
Not the 2415. If you are.
Yes.
Okay, why? Why did you choose that? That's the thing that I couldn't get through to it.
Okay, so if we are writing a measure,
okay,
a measure is not going to be based on row level.
Okay.
A measure is going to be calculated based on column level. So if I write a measure for these 3 records, it's just going to give me a total of this is 35, right?
Yeah.
It's going to give me a 35, for instance.
Okay.
And this is going to give me like 969.
69.
So if I multiply this and this together, the values that it's going to give me is not going to be equivalent to if I had these 2 together.
That's right.
So the correct one,
okay, when
you are doing at a column level, you can't use a sum X. A sum X is used for aggregating data. Iterative is like a kind of iterative process. Sum X. When you are done with the first record, go to the next record, goes to the third record. By performing what operation? By multiplying this and getting this. And at the end of the whole iteration process, give me the total of the value of multiplying this together.
Okay.
We use the sum X to get this instead of doing it one after the other. But we created a column, an additional column again. We call it calculated column. You can either use the route of sum X, or you can use the route of calculated column. But whenever you create a calculated column, you still have to write a measure. The measure is what we will write to calculate this sales purchase before we can arrive to this. And that is a long process. So instead of going through the route of writing or creating an additional calculated column, why don't you use a sum X on the fly? So sum X does all the multiplication and do the addition for you. That's a single step. But for the calculated column, you just have to create a calculated column first and do the measure. So this is taking too long, but the result is the same thing. But for performance sake, if you don't have any other DAX expression that's going to be depending on the column here, if we don't have any DAX expression that is going to be dependent directly to this sales purchased column, it is better to use a sum hex. But if you have other DAX expression that is going to be using this calculated column, it is better we use this.
Okay.
But the same thing, both ways gave us the same result, right? But this is the best route with the best performance. Does that answer your question?
Yes, it's okay. Thank you.
Welcome. So let's go to the next one. The next one is the average. The average and the average hex. The average and the average hex is still the same thing as the sum and the sum hex. What the average hex does is that the x is always taking an expression, right? X is an expression, table expression. And the expression is what? The unit sold multiplied by the transaction price, right? So let's just go back to this. So let's create a new measure. Let's do average. Then we'll do average. Then let's do transaction price. Please give me 1 minute, please. Sorry for that. So we've created our average. So let me bring in a new visual, and I will make it a card, and I will select my average. So the average is 336, right? So let's create a new visual for the average hex. It's pretty similar to the way we wrote our sum x. So we do average x, then I'll do average x. Then can you see it's still table and expression? And here my table is what? It's transaction. Then I'll do my comma, and my expression will be what? Will be transaction units sold multiplied by transaction price. So let me bring in my new visual, and let me do my card. Let me bring the average x. Can someone, based on the sum x, can someone explain this in a layman language, what the average x is doing? Please, you guys should give it a shot. It's not gonna hurt.
What average is doing now is that in sum x, what we did was to sum all the the values that we have in the column. If you look at the approach we use for the second one, where we had the calculated column, then we now sum together. So what we have done now is just taking the average, whereby all the summation together multiplied by the number of rows that we have, giving us an average.
Oh, thank you, Mr. ID. Does anyone have any contrary opinion? If not, so let's go to the next one. So I want to clarify something about the average A, because I don't have a data type that supports that in the transaction table. But I will just explain what the average A does. The average A function takes a column and average numbers in it. A column, like the price column in transaction table, but also handles non-numeric data type according to the following rules. Which means if we have like a string, what do we mean by non-numeric? Non-numeric means anything that it is not number. Anything that it is not number, like alphanumeric, the average A function will still work. The values that evaluate to true will be counted as 1. Which means the average A function works with what? With Boolean data type rather. It says the value that evaluates to false. Maybe, for instance, let me just make let me use my annotate notation to let me do DAX, and let's do this. Let's say I have a table 1. Let's say table 1. And my table 1, the first record, row number 1 has 12, and row number 2, second record, have, let's say, Abe, and row number 3 has 13, and row number 4, let's say row number 4 has true, and row number 5 has false, and row number 6 have nothing. Let's assume this is our record. We have 6 rows, and we're with values with non-numeric values. But here, the rule says, let me expand this here. I'll try and take this. Okay. The rule says, the first rule says, values that evaluate to true count as 1. So here, I denote this with T. I assume to be true, right? So whenever the average A is conducting or probably aggregating its function or performing, it's going to give this T to be 1. And any non-numeric value that it is F is going to give it a value of 0. Empty text, which is blank, is going to be count as what? It's going to be count as 0. So by the time you are using your average X, what we have now is what? Can someone tell me what the average value is going to be? We have 1, 2, 3, 4, 5, 6, right? We have 12 plus 13. 13 plus what? Anyone want to try?
And that would be 25. Are you talking about average X or average A?
Average A.
Average A, I think from what the message here is that if it is not a true value, it will be 0. If it is true, it will retain it. Whatever it has, 12 will be there, 13 will be there. Average T and F will be turned to 0, and it will still do the calculation 25 divided by 1, 2, 3, 4, 5, okay, or 6. It will be the blank one.
The evaluates.
Why not the 26? It should be 25 plus 1. That has
where is the 1?
When it says true is count as 1.
True is count as 1.
It's 26.
Yes.
So this will be 12 plus 13 plus 1. So that will be 26 divided by what? Divided by 6. So that's the difference between the average A, average X, and average. So can someone tell me, technically, what can we use this average A to undo? Anyone want to try? So basically, we can use this average A to undo errors. Maybe you want to do a calculation and you don't want it to return an error simply because the column contains both integer and non-integer value. The average A is the best function for us to use. So that is that. Let me delete this or drawings and close it. So this is the chart here. And so we have 0, 1, 2, 3 to be count as 1. 20 should be count as 1. This is like half a numeric. This is as like ends /8 count as 0. Any blank values count as 0. And any true values count as 1. So that is that. Go ahead, Mr. ID.
Yeah, Mr. B, I just want to find out, is it seeing true and T as true? That's just my clarification.
Yeah, I denoted
because that's why I didn't bother to add that one to it the other time.
Yeah,
so,
I think the mistake is from my part. I denoted the T with true, the true with T rather.
Okay.
Yeah, so just for the short form of it. So the next one is median, the geometric mean and the geometric mean S. So I want to believe everyone know what the median is. So let's just write the median so that just for us to see. So we have the average S. Let's bring in a new measure. I just want everyone to be, please, for the sake of those that are very new to Power BI, this short code, if you can probably practice it tomorrow or anytime this week before our next class, it will make you to be very, very comfortable in writing this code. These are just short things. I decided to introduce us into this mathematical and statistical function just for us to be comfortable in writing the DAX expression. I know most of us are very comfortable writing DAX expression, but for the sake of others that we are just learning, because I also learn every day anyways, don't just overlook this. After this class, watch the video and try to get your hands dirty, as Mr. ID always says. This will make you to give you more confidence to interact with your system, your Power BI, and to even know how to do like a troubleshooting, because troubleshooting is part of what a data analyst should know very well. So let's do median. I will do median. Then I'll do median. Okay, so this is pre-built. Let's do median. Do single quote. I'll do transaction. Let's do media price. I'm going to do my tab. Close it up. And this. Is Mr. Alex on the call?
He is.
Yeah, I'm here.
Yeah, is everything okay?
I'm listening.
Okay. If you have any issue, please speak up. I sincerely I thank to fall in love with Informa these days because I love a spirit of speaking up. And Madam Fumilayo, please, you also need to probably speak up if there is anything so that I just want to, this is the foundation. This is the foundation of whatever I want to write in DAX. So by the time we are able to get this right, because by the time we are combining two functions together, I don't want you guys like, Abby, how do you write this? Abby, how do you write this? Do you get what I'm saying? So everyone should talk, please. So let's bring in the new measure for the median, and let's choose this card, and let's bring in our median. So let's bring this here. Bring this here. And the next one is going to be our median X. I think I will give you an I will give you an assignment, and the assignment is that I want everyone to do this and log in using your own personal email anyways, and take a screenshot of this and send it to my email. Please, I have my reason, because by the time we get to the most a little bit advanced one, I want to make sure that you guys have practiced it so that we'll be able to communicate. Simply because at some point I might be struggling with adding a double quote or single quote or a comma or something. You guys should be able to tell me, Abe, you know what? I think you need to add a quote. I think you need to add a comma. You are missing a comma. That is the essence of us meeting every Saturday and Sunday. I want everyone to contribute, please. So let me write a new measure for median X. Okay. So it's pretty very similar to what we'll be writing. I just want to write this so that everyone will be comfortable with it. So the median X, so we'll do median X tab. Then I'll do my table to be transaction table. Then can you say it's a comma expression? I'll do my comma, and my expression will be transaction unit sold multiplied by single quote transaction price, and I'll close it up. So here I'll change this to my card, and I'll choose my median X. So we also have for geometric mean. Instead of calculating your geometric mean by it going through each of the record one after the other, we can also write for the geometric mean. The geo mean means geometric mean, and geometric mean X means we can perform a geometric mean when on two different columns. That is the mean. It's pretty very similar to what you'll be doing. So let's do that as well. To you, it might be, to me, it's just a way to introduce it into this. Pretty very easy. I remember the first time I wrote my first Python code, I was so very happy. So just try this on your own as well. It's not a big deal. So let's write a new measure. Then I will do geo mean. Then I'll do geo mean. Can you see we have it there already? And I'll do my single quote for transaction. And I'll do that for transaction price. So I'm going to write another one for the geo mean X. So after that, then I can bring in my measures for the two and just put it on the canvas. So I will do geometric, geo mean. So I got all this from the Power BI DAX sheet file or sheet. So I just want to make sure I follow the curriculum, just starting from the introduction part, how to write simple DAX expression, and then gradually go into the advanced one. So let's do geo mean X, and let's do the transaction table. Then I'll do the comma. Then I'll do transaction unit sold. We can also do the product first, then do the transaction price, and I'll do this. So now we have the geo mean and the geo geomean X. So what I will do is that I'll come here home, then I'll click on my new visual. Then I'll select my geomean. I'll change this to CAD. And I can also copy this. I can copy the visual. And I can do Control P, I think. Oops, sorry. Trying to get this to look smaller. Okay, let's click on this. Okay. So we have, let me bring my new visual. I'll make it this. Zoom in. And I'll do new visual. Make it zoom in. Next. Make it visual. Can you see a pattern here in what we are doing? Can you tell me the pattern that you see in when you look at the attribute with the hex, the version of each of the function with the hex compared with the one without x? What do you see? There is a trend here. I don't know if you noticed that.
The x is higher than those one with x. Some x, average x, geo x, and co is higher than this, the ordinary one, because we're actually looking at a price alone for all this one, but we are looking at two variables for the other one. Okay. And taking the average of some or whatever.
Yeah. So this is another method for us to always read, like have a knowledge on how to read the trends and the pattern in what we have, the visual we are putting in our canvas. But this is what the end user is going to take a look at. They will consume it to make a business decision. At a glance now, I can easily say, okay, you know what? I think if I'm not a data expert, or I don't even know how to read the data, I can ask whoever that designed or that developed this or come up with this, that why is it that the hex we are having larger values compared to the small one? You know, as a data analyst, you should be able to tell them, you know what, we are probably aggregating two columns to derive the value for the version that have the X. And for the one that without the X, it is just done at a column level, right? So you should know the best way to always put your answers to a non-data savvy person, to a non-data analyst person, because the end user wants you to build a report that they will be able to consume at a glance, instead of coming back to you and telling you, Mr. ID, you know what? I don't understand all these your terminologies. Do you want to tell me what this means? And that is the reason why you must ensure that there is no communication gap when you are building your report, so that you'll be able to use a word that they are familiar with. A nurse or a doctor or a physician or a clinician, the way they will call their attributes might be different from the way you will call it. It is always very good to name the title of your visual or the title of your report based on what they believe it means. You must never assume when given the title. So most times when I build a report like this, I always go to the end user to ask them, do you think this title is fine? You know what? Use so. This is what we call it. So it is very, very important. It's not just about just building the report. The communication is key, because most of the feedback the customer are going to give you at the final stage of deploying your report of validation, it's going to go a long way, simply because they are the one using the report. You are just building it for them. So always learn to use a layman language, or probably use the terms that is probably related to the industry or to their own business operation. So that is the standard. And this is also part of governance anyways. So let's go to the next one. So before we go to the next one, we have count, we have count A, we have count X, and we have counter X as well. So in the count, the only argument allowed for this count function is a column. I want to count the number of rows in a particular column. And a count will work for these three values. Numbers, you can count a column, a table that has a column, strictly numbers. You can count a table that has a column of date. You can count a table that has a column of string. You can also use a count row to count a table, to count the total number of rows or record in a table. Note, when the function finds no rows to count, it returns a blank value. Blank values are skipped. True or false value are not supported. If you want to evaluate a column of true or false value, use the count A. Excuse me. Use the count A function. If you want to count a column that has a true or false value in it, we have to use the count A function. If we want to count a column that has number, that has date or true, and that has string, we have to use the count function. Sorry. So this function is not supported for use in direct query mode. When used in calculated column or row level security, for best practice, when using count, use count row. So there is an hyperlink here that you can click on to read more about the count row and the difference between this count, count S, counter X, and count A. So, okay, here. So let's just do count. Then we'll do, I don't have a column that have, I won't be able to write the count A simply because I don't have a column in my transaction table that supports Boolean data type. But I will write the count. I'll write the count, counter X, and I'll write the count X, just for us to see the difference. But majorly, the count A counts the number of rows in the specified column that contains non-blank value. When you want to count a non-blank value, you can use counter A. When the function does not find any row to count, the function returns a blank. Unlike count, counter A supports Boolean data type. The count does not support Boolean data type, but the count A supports Boolean data type. What are Boolean data type? The Boolean data type are 0 and 1, true or false. So head or tail. This function is not supported for use in direct query mode. It can only be used in the import mode that I showed when we started this class. So these are the little things that we need to pay attention to. So let's write for the count. So we write for the count. We write for the counter X. So before I write the counter X, let me just explain this to you. So the counter X, I want to give you a clue. If you want to read a DAX expression, always start from the inner part. Always start from where? From the inner part. So the inner DAX expression is what? Filter. I say on my employee table, filter on my employee table, where the job title is equals to buyer, and return the correct flag of that employee in the employee correct flag what? I'm filtering this employee table based on the employee job title and what? return the employee current flag. This is an expression. Let's just give it a shot. So let's do new measure. Let's do count. Let's do count. I'll do count. Then I'll do count transaction. Can you say column name? Count column name. Let's do price. So now we have our count. The next one for us to write is the counter X. Right? Simply because I didn't have any of my column in my transaction table that has a Boolean data type. That is the reason why I won't use this count A. Or you might want to try that on your own. You can just come up with like a kind of a data set, just come up form a data set, maybe just 5 or 6 records, and just use that to as a practical, as an experiment, to see how the counter A behaves compared to counter X. So let's write the counter. Let's write the count X, and afterwards then we'll write the counter. Let's write the count X, and afterwards we'll write the counter X. So the count X, let's do new measure. I'll do new measure. I'll do count X. Then I'll do count X. Do count X. Can you see it's a table? Then I'll do single quote transaction. Then I'll do column. And the expression will be, what do you want us to count? Transaction. Okay. So let's do transaction, then transaction price. Let's see the difference. So let's bring in our home. Let's bring in our new visual. Let's do card, and let's bring the count. And let's do new visual. And let's do card. And let's do count X. Can you tell me the reason why the count X and the count give us the same thing? Simply because we are using a clean column. We don't have any mixed value or mixed data type and stuff like that. So let's do the counter X. Let's do this. Let's do the counter X. So for the counter X, we want to filter the employee table. The employee table, where the job title is buyer, and the employee current flag, comma, employee current flag. Let me do something for you so that you can understand what I'm trying to write. If we go to our table, we have the employee. Let's select the top 1000. So here, what I want to do with my counter X is that based on this table, this employee table, I want to filter I want to count only the job title that is equivalent to buyer and the current flag. And that is what we have here. So here, I'm referencing this column, this current flag column, and this job title column from my table. What I'm trying to do is that I just only want to see this job title, just the buyer. I'm only interested in seeing the buyer. I want you to count the number of buyer that we have in our employee table and display the employee current flag. So for the sake of time, let me just copy this. And I'll create a new measure and call it this counter X. Counter X. So from my employee table, I have my employee table here. If you take a look at my let's see. Yeah, so I have my employee table. So before you can write any DAX expression, your data must be in the model. Your data have to be in the model. It must have a data table, about that table in the model. So now, on my employee table, I just want to say the buyer, the job title buyer, and I want the employee current flag. Okay? Filter on this. Filter on this. So I'll do enter. Then I will do home and I'll bring my new visual. Then I'll make it a card and I'll select my counter X. Can we take a look at something? Let's try and see. Let's try and see. Let's throw in a where clause here. Where job title equals. Is it a single quote or double quote? Is it single or double?
Single.
So we have just nine records. And everything is one. They are buyers. So these are another method for you to do your data validation whenever you are building a report. Because the Power BI also have like a kind of sort arrow that we have in Excel spreadsheet as well. If the record you are working with is not so huge or probability is huge and you can still filter, if you click on the filter, it will display the total number of record. So now, using this DAX expression, that shows that based on what we use the SQL to undo, it shows our counter X DAX expression works. Do you have any question before I proceed? So I think I've explained this. And the remaining one, okay, I think this is very, okay. Mr. ID, go ahead.
They can't, sorry, let me see. Can we?
Go ahead, we can't hear you.
They count X. Can we use it for just one variable? The other ones we have been doing, we've been looking at two columns together to do some whatever. But this time around, we are talking about just units sold alone.
Okay, so let's go back to our counters. The countx function takes two arguments. The first argument must always be a table, right? This is the table, or any expression that returns a table. The second argument is the column or expression that is searched by the countx. The countx function counts only values, date, or string. If the function finds no rows to count, it returns a blank. If you want to count logical values, use counter x. So in most times, the count x, you know, when we wrote our count, can you say? I just say count transaction price. This is a column. This is not a table. But a count x will take a table and the unit you want to count. So you can't use a count x with just a column. You have to specify the transaction, the table name, and the expression. The expression can be a multiple expression or it can be a single expression. In this case, this is a single expression. Does that answer your question?
Yes, that's right.
Okay. So before I proceed, I want someone to take a look at the divide function. Can someone explain what this DAX expression, based on what I've shown you, can you just explain this in the layman language?
Like 14 now, you are using it to divide, I think, introducing the function divide for the price sum, then sum of the transaction, that you are summing the price divided by the sum of the units sold.
Okay, let's do something. Let's do something. Let's do this. I have to. Okay. Yes, I have to. There's always a way to format all this as well. You can select all and just arrange it. Just looking for a space to put my new visual. Okay, I think I can put it here. So let's do divide. Let's write a new measure. Oh, sorry, I click on visual. Let's do new measure. Let's do, I'm going to name this to be divide, right? This will be divide. And I'll do divide. My numerator, I want to do sum of transaction. I just want to use this for division's sake. I don't want you to quote me if the value is correct or not. I just want to show you how the division syntax works. So I'm going to do the sum of, let's say the sum of price. Let's just use that. Okay, let's do this. We can do the sum, divide sum, or I can sum creating a new measure. If you create a measure and sum, if you create a measure and divide it by another measure, it's going to work. But I think the best way to handle that in terms of performance is having a single operation, a single measure that's going to handle a multiple expression. So to do that, let's do tab. Then I'll close it. Can you see how it displayed? Now I have divide. I've undo what? I've undo my numerator. Now I want to do what? I want to undo my denominator as well. I can do another sum. I will come here. Again, this is just to show you how to use a divide function with other function. Then I will do sum. I can do my transaction. And I will select the first one is price. I'll select the total units sold. And I'll close it up. You can see immediately I close it up. It's expecting what? It's expecting a comma. Then I'll do my comma. If that result doesn't give me any value, if it is blank, give me an alternate result. I want you to give me 0. Give me 0 as my alternate result. Then I'll close it up. This is a way to combine a divide function with other function in DAX. Some people might choose to write a measure and divide a measure by a measure. Again, don't quote me. I'm not looking at doing a calculation to see if this value that this divide function is going to give me is correct or not. I'm just trying to show you how the divide function works with other function in Power BI. If you take a look at the example we have in our Word document, you can see I say that divide price sum. This price sum is a measure that was generated. That's the measure that has been written in the Power BI. Let me show you that. I think I have it here. Maybe it's part of what I deleted earlier. So, but in this case, I use the sum to handle everything. For the sake of those that does not know how to write a complex DAX expression, they might want to write this separately. Like this is a measure, and this is another measure. Then later they will now throw in their divide. I'm calling the whatever name they give this their measure for the one that starts from the sum all to the price. They will give it a name, and they will give this sum transaction unit sold another name as well, and they will now divide it and also insert their alternate result. That is a long process. The main reason, again, I'm going to iterate this. The main reason why we start with this simple basic mathematical and statistical function in Power BI is for us to learn how to combine multiple functions in Power BI when we are writing our complex DAX. So now you can see that I've used the divide and sum. I can decide to use the divide, but professionally, it's not really okay. Performance-wise, doesn't make any sense. But take a look at this. This is actually going to perform better off. Instead of writing a dedicated measure for this and writing another one for this, and now introducing another measure again to calculate the sum of this and the sum of this. Doesn't make any sense. So let's tap the enter. And I'm going to change this to be my card. Right, and I'm going to select the divide. So that's that. Don't quote me again. I don't know if this value is correct or not, but I just show you. Go ahead, Mr. ID.
I want to ask, why do we have this 0?
Yeah, so the 0 is that if the result that we get here, if this doesn't give us any result, when they say alternate result, by the time we start writing the DAX expression, like, okay, for instance, do you remember when we are writing the VLOOKUP, we always have true match, exact match, something like that. So whenever you are writing, you are dividing something. For instance, maybe we are dividing 4 divided by 2. It's going to give us 2, right? So if we are dividing, let's say we are dividing 1 by 0, maybe it's going 0 by 1, maybe it's going to give us something. In order for us to undo an error, do you get what I'm saying? This 0 is handling the error. If what we are dividing is not giving us a value, it's not giving us a result, return 0. That's what it means. That is the alternate result.
If it's in decimal, it will give us the whole number 1.
So if it is decimal, this is a decimal. This is 1.72. No, there are some things that probably they are not divisible. Okay, let me put it in the right way for you. Maybe you are dividing a non-numeric with a numeric value. Instead for it to be throwing an error, it will return 0.
Okay.
Just for whenever you see 0, it's always for error handling, so that we don't have something that does not work. Instead of having like maybe I don't know what is going to maybe like an error or something here.
Like that error or something.
Yes, it's just going to return 0.
Okay, thank you.
So the next one is the mini and the max. We are just trying to get like let's obtain the lowest value from our unit sold, and let's obtain the highest value of our unit sold. Something like that, just min and max. So let's do that. We'll do new measure. The new measure would do, we do mean. So we do mean, then can you see column or scalar 1? Do my transaction. Then I want to do my unit sold, or I can do anything. Then I'll close it up. So let's write for the max as well. So we do max. We can do max. Then we do transaction. Most times, all these max and minimum can just be for like trying to do like a kind of a descriptive analysis, or trying to understand what your data has holds. And also we can also use a SQL query if you have an opportunity to SSMS server. You can just write that to see the highest value in the particular column and the lowest. It's pretty something like, it's very easy, like something like that as well. So we have the max. So let me bring in my visual just for me to display the value. I will do where's my mean value. Sorry, this is gonna appear so can I say erratic, unarranged, it looks untidy. I just want to show you, and I'm gonna put in my max there. Let me throw a new visual. It's gonna change that to card. I'm gonna bring in my max. So if you go into the table of our unit sold, the maximum product sold is, I think, is 188 or something like that. So that's that. So the last one is the count row. The count rows is if you want to count the total number of rows in a table. This is the syntax to use in DAX. But this is also going to be equivalent to the total number of rows of records in a column. It now depends if that column has a blank value. If it has a Boolean value, it depends on what conditions that cell, particular cell, holds in that column. But if you just want to count the number of rows for a table in Power BI, the count rows is the syntax to use. So let's do that. I'm going to do new measure. And another thing that you notice is that a measure is always returning what? A single value. A measure will always return a single value, Why a calculated column will always return a single value for each of the record. Count rows. To count rows. Can you say table? Then our table name is what? You can do the count row for employee or password or whatever. So do that. So let me throw my do new visual and make it card. I'm gonna make it so small. Bring it here and do my count row. Wait, the count row is 20,000. Let me see. Is that possible? Do the call out value. Okay, it's 19,972. The count row is for, let's see, password. Can that be possible?
I would do for transactions, so I will be sure that you can compare with other.
Okay. I even want to do the password. Let me check the password, please. Yes. I want to check the number of. I never knew we have a record as much as that. Oh, that's correct. 19,972. So let's change this to the transaction as suggested by Mr. ID. So 365, yeah. All right. So distinct counts. So if I want to count the distinct value in a particular column, okay, for instance, if we have a table that has a table that has a column of gender, and the gender has a male and female, what is the total number of distinct count in that column?
That should be 2.
Yeah. So distinct count means the count is going to select every unique value. If you have 7 females and we have 3 males, the unique count of value in that column is male and female. So that is what the distinct count does. So let's do the last one. It's going to be the distinct count. So let's do the home. Let's do the new measure. So let's do the distinct count. That's distinct count. And let's do distinct count. Let's do the distinct count for the, let's do for the price. So let me bring in my new visual, make it to the card. And I'm going to put it here. I'm going to select this. So the unique count that we have, the distinct count that we have for our price on our price column is 30. So That is that. Do you have any question? I think today's class should be one of the most easiest class so far. Is anyone finding it difficult to understand anything? Questions, concerns, roadblocks? So these are all the measures we created. And again, a measure will always return a single value for you. A calculated column will also return a single value for each of the row. Let me show you that again. Let's go to our transaction. You can see also this is a calculated column, and a single value was returned for each of the record. For each of the record, it's a single value. This is a single value, and whenever you write a measure for a calculated column, it's going to also return a single value. They might ask you, can you write a measure for a calculated column? The answer is yes, true. So that is that. Any question before we call it a day?